Welcome to Built, Wired, and Secured, the podcast where we explore how modern buildings are designed, connected, and protected in the real world. I'm Alex Wagen, and in today's episode, we're diving into observability for buildings, turning systems into insight, why it matters, where projects usually go wrong, and what decision makers need to understand before problems show up in production. Joining me today is Michael Harrington, who spent decades running building operations across office campuses and mixed-use properties. Michael, great to have you.
Thanks, Alex. Good to be here.
Cold open. Imagine a downtown office building where tenants started calling reception about warm floors and slow elevators over the course of a week. The facilities vendor had been sending low-priority emails about a pump vibration threshold. The BAS alarms were spiking on different vendor portals, and nobody had a single view. By day 7, a chiller tripped, the building lost cooling, and half the floor tenants had to move meetings. Operators spent the day arguing over which alarm to trust, while tenants felt the impact. That's the moment an observability mindset would have stopped the escalation before it became an outage. In plain terms today, we'll define what metrics, logs, and traces look like for buildings, and show how a few practical changes turn noise into action. Metrics are simple numbers you track over time, like chilled water flow, elevator door cycles, or badge swipe rates. Logs are discrete events, equipment alarms, vendor alerts, error messages. Traces are sequences, how a power issue ripples through systems. Treating these signals as a system matters for uptime, tenant experience, and operational cost, not just for catching dramatic failures, but for stopping slow degradations before tenants notice.
Exactly. From an operational standpoint, you don't need every single data point to be useful. You need the right ones. The problem I see most is signal chaos. Dozens of vendors, each with their own portal and alerting rules, and staff who stop trusting notifications because most of them are noise. That's what hides slow failure modes. Tenants feel it immediately, but by then, it's already complicated to diagnose.
Let's unpack causes. What creates that signal chaos? Start with vendor silos, inconsistent telemetry standards, and alerts that aren't meaningful.
Right. Vendors deliver useful telemetry, but it's often proprietary, inconsistent, or only visible in their dashboard. You end up with a dozen dashboards, and nobody correlates them. There's also a cultural element. Teams treat alerts as urgent until they're wrong repeatedly. Once that trust erodes, staff ignore them. And don't forget intermittent telemetry problems, packet loss, clock drift, misconfigured thresholds that cause alarms to trigger at the wrong time and hide trends that matter.
So the root causes are both technical and organizational. How do slow failures hide? Give listeners a concrete example of a subtle drift that becomes an outage.
We saw a chilled water loop where flow rates dropped gradually over months because a variable speed drive slowly lost calibration. Individual vendor alarms showed nothing critical. The chillers reported healthy, pumps reported running, but no one tracked flow as a metric over weeks. When the outdoor temperature spiked, system capacity evaporated and multiple floors lost cooling. That's the classic case. No single alarm, but a slow trend that would have been obvious with a simple metric and an alert on sustained decline.
Let's move to trade-offs. If you can't instrument everything, where do you start? What's the pragmatic path for teams with small budgets and limited staff?
Start with single points of failure and tenant-impacting systems, central chillers, main electrical distribution, key network aggregation points, access control backends, and the elevator control logic where possible. Instrument those with a simple metric set: availability, response time, and key performance counters: flow, set point deviation, power draw. The staffing trade-off is also key: centralize dashboards and assign ownership. One person or a small team should own the alerting rules and escalation paths. Otherwise, alerts land nowhere.
And tooling trade-offs? Do you buy a single observability platform or use lightweight open tools?
Both models work. Commercial platforms can accelerate correlation, but come at cost and sometimes vendor lock-in. Open tools and normalized metrics, for example using Prometheus-style metrics or simple time series databases, let you standardize telemetry across vendors. The real requirement is normalization.
Define the metrics you care about in contracts and handoffs so vendors deliver comparable data. Then you decide whether to consolidate or federate dashboards based on budget and staff capacity.
Alert fatigue is a huge human factor. How do you tune alerts so staff respond instead of muting them?
Treat alerting like a product. Start with 3 tiers: informational, logs and trends; warning, sustained deviation needing attention; and critical, immediate tenant impact. Only critical alerts should trigger page calls after business hours. Use staged escalation, an email first, then a text for warnings, phone call for critical. Review every alert that fired in a post-incident review and adjust thresholds. If an alert is noisy, either change the threshold or change the signal you're alerting on. That review process rebuilds trust over time.
Let's talk implications. How does improved observability change vendor relationships and capital planning?
It changes the conversation from feature lists to measurable outcomes. When telemetry is available and normalized, you can hold vendors to SLAs that are meaningful, not just device online, but sustained flow within 5% of setpoint. For capital planning, metrics reveal chronic inefficiencies early. Instead of reactive replacement after failure, you can plan targeted maintenance or upgrades based on trend data and actual performance, which lengthens asset life and optimizes spend.
And governance. Who should own the dashboards and alert rules in a typical property organization?
Operationally, facilities should own the alerts for tenant-impacting building systems. IT should own network and cyber-related telemetry. A joint governance board, even small, monthly, helps where systems overlap. The important part is documenting ownership, escalations, and what to do when an alert fires. That avoids the not our problem finger-pointing during incidents.
War stories time. Michael, share a couple of pragmatic examples. One low-cost instrumentation trick, and one case where metrics actually prevented a big outage.
Low-cost trick first. Add a simple flow sensor and a small IoT gateway on a critical pump, and stream the flow metric to a shared time series endpoint. Cost is a few $100s, and the visibility is immediate. It turned a black box pump into a predictable asset. The prevention story: at a campus, we monitored the delta between supply and return temperatures across the main loop. We set an alert for a sustained divergence pattern overnight. The alert fired for a 2-week gradual separation. Staff investigated, found a fouled heat exchanger, cleaned it on a scheduled window, and avoided a chiller replacement and tenant complaints during a summer heat spike. That saved tens of thousands and a lot of reputational headache.
That's the kind of practical return teams can expect. All right, before we wrap, let's give listeners a concise checklist. 3 things property teams can do this week to improve visibility.
1. Identify your top 3 tenant-impacting systems and define 2 metrics for each: availability plus 1 performance metric. 2. Consolidate telemetry where possible. Even a shared spreadsheet or time series endpoint is better than siloed portals. 3. Assign alert ownership and schedule a 30-minute weekly review to tune thresholds and retire noisy alerts. Those 3 steps create traction fast.
If you want templates for those metrics and an example escalation matrix, visit our episode resources. That wraps up today's episode of Built, Wired, and Secured. We covered a practical playbook for turning building signals into operational insight, and hopefully gave you a clearer way to think about how these decisions play out beyond the initial install. Thanks for spending time with us. Michael, any final thought?
Remember, instrumentation is an investment in predictability. Start small, standardize outputs, and treat alerts like a product. Do that, and you stop firefighting and start preventing. Thanks for having me.
Until next time, make sure the systems you're responsible for are built to last, wired with intention, and secured for the real world. Built to last, wired with intention, secured for the real world.